Hi everyone, I hope you're all doing well this week, and I hope last week's lab was helpful. For all that reached out to me about some problems with their data, I really recommend working on a desktop. I know a lot of you don't have them at home, which is totally fine. I don't either. I'll be working from a laptop today. But if you do decide you want to work from a desktop computer, you can email Susan Taylor, and she can grant you swipe access to the third floor computer lab if that's something you'd be interested in. So this week we're going to be going over lab 2. So let's go ahead and get started. Alrighty, so just like last week, the first thing we're going to do is scroll down to our lab materials and open lab exercise 2. Like I said last week, I do recommend opening this up on another screen, either your phone or anything else you might have, because it can be hard to open different windows. So our objectives today are going to be tabular output, so frequency tables, crosstabs, and then we're going to work on graphs and charts, pie charts, bar charts, histograms, and stem and leaf plots, and when and where we should use these graphs, and what graphs we should use them for. So the data we'll be using this week is the same as last week, demo.sav, and you should all have that already downloaded. If not, you can find it in the lab data section of modules. All right, so firstly, we're going to go over a PowerPoint for today. Alrighty, so raw data is basically all the numbers we're going to be working with. This is kind of what the demo.sav was. It can have, gender or marital status, and this is actually from a data set representing fuel efficiency for miles per gallon. So a lot of numbers. And how do we make these numbers work for us, and how do we make them look meaningful and represent them graphically? So first we have a histogram representing the miles per gallon. So we can see that most cars are falling in between, like 14, 15 to 20 miles per gallon. If you drive a Prius, maybe you're up here in the 30s or 40s. So this can show where the averages are falling, what categories have the most frequency of efficiency. A table can show a lot more than that. You can represent the months and average high temperatures like this one shows here. And it shows a little bit more data. So here's some more raw data, annual vehicle travel from a sample of Florida drivers. And this is miles of travel. And a frequency distribution for that might be mileage data, where you have groups of different mileages, so 0 to right under 6,000, and then another grouping of 6,000 to 11,999, and so on. And you can see the frequency of how many people fall into those categories, or how many respondents fall into those categories, with the total summarized here. Another example, feelings about classical music. And this is more of a descriptive statistic where, it's based on opinion. So this is how many people answered that and the total number of respondents. Another one about annual vehicle miles traveled, similar, but this one actually has percents. So that can show kind of a more generalized grouping and show what each category looks like compared to the whole. So you can easily look at this and see, oh, the most people are only averaging 0 to 5,999 miles per year. Another example of that, we can see that most people in this sample are married. Another one here. So common graphs, I hope most of you have seen these before. And some that we're going to actually make today. We're going to make a pie chart and a bar graph. We're also going to be using histograms, stem leaf plots, box plots, and scatter plots. These are for quantitative data, and these are for categorical variables. So an example of a pie chart, I think these are great for graphics, but they can be hard when you print them because sometimes the colors don't show up. So if you have more than one variable here that you're trying to display, you want to make sure you're using contrasting colors. Another example of a pie chart, but in 3D. And great idea, keep it simple. It's good for representing pretty simple data. The less slices you have of a pie chart, the better. Here's a legend. And then we have a bar chart with marital status represented. Another bar chart. A 3D bar chart. Another bar chart. And like I said, keep it simple. And here we have a histogram where our bars are touching. Different from a bar chart because they are in their own groups. It's not spread into a numerical category like a histogram is. These are groupings, All right. So interval sizes do matter. You could have something that looks like this where we're having the most frequency in the middle. And then sometimes there's places where it's blocked off where we don't have any information or no responses to that. And lastly, we have a stem and leaf plot that looks something like this. The data for a stem and leaf plot. All right, so now that we've gone over the PowerPoint, let's go ahead and get into the lab itself. Again, you should have the demo.sav data saved locally to your computer. So if you haven't done that yet, go ahead and do it now. VLab right here. Log in. And of course we have to do the duo push. And we'll go to our apps and open IBM SPSS. Make it full screen. Alrighty. So if you haven't if you don't have your demo.sav uploaded already, we're going to go ahead and go through the upload process, find it and bring it in. I'm not going to go through this because I already have mine in here. So if you need to figure out how to do that, just reference lab 1. But let's go ahead and bring the demo.sav into SPSS. Alrighty, there we go. Okay, so following the click steps, the first thing we're going to do is produce a histogram. So first we're going to click Analyze, Descriptive Statistics, and Explore. After that, we're going to use age in years and move that over to our dependent list. After that, we're going to want to click Plots and select Histogram and deselect stem and leaf so we only are producing the histogram. Click Continue. All right, and after that, we'll click OK. Give it a second, and then we can... 1 second, my computer's frozen. All right, so this is what our histogram looks like. So a note about the statistics displayed on the histogram. In some cases, you want to display the statistics, but for the purpose of this lab, we're going to remove them. So to do so, we're just going to open the chart editor by clicking on the chart itself. We can highlight the statistics, and then we will click Edit and go down to the bottom and delete those. So once we have that done, we can go ahead and close out of the chart editor. Well, just kidding. We're going to open it back up. So go ahead and click on the chart itself again. Bring up the chart editor. And we're going to change the scale of the histogram by double clicking the numbers on the lower axis right down here. All right. So we're going to go and define the maximum and minimum by clicking scale, but we're actually just going to keep these the same for the purpose of this lab. So we'll leave them as the default value, so we can click close after that. So staying in the chart editor, you can change the number of bars on the histogram as well. So double click the histogram itself. And we'll open up our properties box. And then we're going to go to the binning tab up here. After we get to the binning tab under the x-axis, we're going to select custom and change that 60 to 12. So we only are going to be representing 12 bars. And after that, we can go ahead and click apply. And there we go. So now, sorry, frozen. All right. And we can also change the title of our histogram by clicking the title. So let's name it Histogram of Respondents' Ages. Mine's giving me some problems here. There we go. So might have to click it a few times. That's okay. And click enter after that. Great. So moving on, we're going to go ahead and close the chart editor, and it should save our changes just to make sure. Perfect. So we're going to go back to our main raw data page, and we're going to click Analyze, Descriptive Statistics, Explore again, and we're going to keep age in years for our variable, and then we're going to click Plots, and this time we're going to choose stem and leaf and deselect histogram to only create a stem and leaf plot. Now we'll click Continue and OK. All right. So we should have a stem and leaf plot that looks something like this. And now we're going to move on to creating a frequency table. So going back to our raw data, we're going to click Analyze, Descriptive Statistics again, and Frequencies. So for this, we're going to produce one for gender. So you might have to scroll down and find gender. And we're going to click that move over for the variable box. And for this, we're going to go ahead and click OK. And it should look something like that. After that, we're going to create some more graphs for gender. So let's go back here. And to create a simple bar chart, we're going to click Graphs, Bar, Simple, and Define. So after we do that, we're going to move gender into our categorical axis. And click % number of cases. And then we're just going to follow what we did in lab 1 to format the bar chart. So give it a title. Gender of, sorry. Click continue. All right. So after we do that, we'll click OK. And we have our bar chart. Male and female by gender. And if we want to go in to chart editor and change the colors here, we can. So last time male was filled with black, so we'll try that again. And female was white. All right, perfect. So now that we formatted that chart, we're actually going to do a pie chart now. So once again, we're going to click Analyze, oh, pardon me, graphs, pie chart, and we're going to keep summary of group of cases and define. And once again, we're going to be looking at gender. So we'll move that over to the define slices by. And make sure that the slices rep the percent of cases. We're going to give this one a title of well, same thing, gender of respondents. And click continue. And okay. So to add percentages to our labels, what we're going to do is open the chart editor and then right click on the pie chart and open our, sorry, one second. Oh, I actually did it on accident. So you right click on the chart, go to show data labels, and you'll see a number of potential labeling options. So choose the one you wish to use. Sometimes it's appropriate to use numbers, others times it's percents to communicate your message. So for the purpose of this, we're going to do percents. So percent is highlighted and we're good to go. So let's go ahead and change the colors like we did for lab 1. So we can click female and fill with the white and apply. And then male, we will fill with black and apply. Pardon me, I got that backwards. So we're, but you get the gist. You can we'll change it. Let's make female black like it's supposed to be, or like it looks like on your handout. And for male, we'll do white. And it did it again. So female, we will do black. And male, we will do white. And there we go. All right, so that looks like what it should look like in your handout. All right, so the last thing we're going to do is produce a crosstab table. So we can go ahead and exit out of the chart editor and go back to our raw data. For this one, we're going to click Analyze, Descriptive Statistics, and Crosstabs. Now select which variables you'd like to display in the rows and see in the columns. So in the example, we place marital status in the row. So marital status in the row, and then we'll place gender in the columns. Perfect. So after that, we're going to click on the cells button. The default display will be observed frequencies or counts in each cell, but you can also have the table display column percents, row percents, or total percents in addition to in lieu of counts. I'm going to select column percents, which should already. So under percentages, we're going to select column while keeping observed highlighted. All right. And it should sum to 1. So now you can compare the distribution of males and females males versus females on the variable marital status. So after that, we can go ahead and click continue. Okay. And the output should look something like this. So for an example, a larger percentage of females were, pardon me, a larger percent of females were married than males. We've got to make sure that all of our totals are equal to 100%. So that wraps up lab 2. Please email me with any questions. And if you email me, there should be an option to schedule a office hour session with me. And that should be it. I hope you guys have a good week, and please feel free to contact me with any questions. Thanks.